All right, this video is going to help us understand how to find a linear regression line on a TI Inspire calculator. We've already discussed how to find a best fit line, which is you doing the work by hand, but your calculator can be a great tool helping you to find not only either your own model, which would be a best fit line, or letting the calculator find the best fit line, which is essentially called a linear regression model. So you might get a question similar to this. The number of radio stations selected for the years from 1970 to 2000 is given in the table below here. Plot the data and represent it using a linear model. Now, you can still use your calculator for this portion, even though it may not be the best fit line. You can let your calculator handle the stat plot or the scatter plot. You can also let your calculator handle finding a best fit line and actually play around with that line a little bit and determine which line you think is the best fit line. First thing you're going to want to do is take a good look at your years rather than having to type in 1970 to 2000. Since most of those start with a 19, we can consider 1970 to be year 0, which would be a helpful thing to do. It's going to be a lot less to type. Then we're going to just talk about year 0, 5, 10, and so forth. Or if we changed our graph, such as this, we're going to start off with 1970 having been year 0, and then 5, 10, 15 to 30 years down the road. You could also technically change your number of stations, move the decimal point, and put this in as 6.76 and 7.744. Really, you're going to be typing just as many numbers, though. So typing it in thousands versus typing it in terms of being in thousands, either way would be just fine. I've already pre-typed in my data on a data and spreadsheet page, and let me go ahead actually and show you the instructions here on the next page. Now there's a lot of instructions on here. I'm going to walk you through the first couple and then we'll go back and then we'll get down to the red portion. But the first thing you're going to want to do on your Inspire calculator is open up a list and spreadsheet page. So you add a list and spreadsheet page. At the top of that page, it's going to look a lot like an Excel document. You're going to put in the names for your categories. So I put in year and stations and then typed in my data directly from that table. The next thing we're going to do is open up a data and statistics page, and then we will put in the axes that we want and we'll be able to see our scatter plot so that then we can create a movable line, or what would be the best fit line. Not the linear regression yet, but just the best fit line for our data. So let's go ahead and go back to our calculator here and we'll show you how to do that. So this is your data and statistics page, just like we were talking about here in step number 3. Or sorry, this is your list and spreadsheet page, just like we're talking about step number 1. I've got the data all entered in, so now we need to open up another page. So I'm just going to press Control, Add Page, and let's put in a data and statistics page. So you'll notice our data is all over the page right now. If we click toward the bottom, we're going to be able to pick that we want the x-axis to be the years that we're looking at. And if we click over here on the left side for our y-axis, we can click on stations. And now we get that nice scatter plot. Then if we want to create that best fit line, we're going to go to Menu. We're going to Analyze part of our graph. And we're going to add a movable line. A movable line is just a best fit line. It's a line that we can move around wherever we would like to. So it threw the line on there, and it might look pretty good already, but it's giving you the opportunity that in the middle we can slide that line up and down. And then if I put that near my initial piece of data there and I go over to the end, you'll notice the 2 rotating buttons, and I can pull that data and we can pull it down this way to see if we can't line it up somewhere toward the middle of our data. All right. And just for argument's sake, I'm going to put my line a little bit too low. I'm going to put my line a little bit below my data, just to show you what can happen and where our better fit line will be. So notice how most of my data points are above my line. That's not where I would normally put my best fit line. But you will notice that we do get a reasonable equation, 213x plus 6,333. There's our y equals mx plus b equation for our line. So that we could go back to our page here, and if we wanted to, we could write down that equation, and we could also answer the following question. Assuming that the linear pattern continues, predict the number of stations in the year 2020. Well, if 1970 is year 0, 2020 would be year 50. and we could plug in and figure out, do we think that'll be a very good prediction in the year 2020. Instead, however, I'm going to go ahead and create a linear regression model. Let's go ahead and switch up what we're doing. So I'm going to go back to the calculator. First thing I'm going to do is remove my movable line. So I'm going to take a look at it and say, well, analyze. Let's take out our movable line, remove the movable line here. And now, instead, I'm going to analyze and create a regression. And notice we have a lot of choices for regressions. We typically use linear at this point. So we're going to do a show a linear y equals mx plus b equation here. And notice it throws it on there, gives you that equation. And notice fairly similar to our old one, but again, it's going to go right through the middle of that data, a few pieces a little bit below our data, and a few pieces a little bit above. And in fact, if we wanted to, we could even move a piece of our data. If I took this piece up here and we slide it down, notice that it actually moves your linear regression line, because that line is based on where those pieces of data are every single time. So we could move that data and kind of mess with that a little bit. But in this case, 209.257, so y equals, let's go ahead and write that down, y equals 209.257x plus 6733,857. 6733,857. That is going to be our linear regression line, the best fit line. That's what this is, best fit line available. So there you go. Now, in order to predict in the year 2020, we essentially want to plug 50 in there, which we could retype all of those numbers if we want to. But a better idea is down here in the red. Note we did all the other parts on our data and statistics page. This requires us to open up a calculator page. We're going to redo the linear regression equation, and you'll notice that we get those same numbers we had before, 209.257, 6733.86. It rounded off a little bit, but we're going to get all those numbers, and it's going to give us a correlation at the bottom as well. Notice 0.994, which is really close to 1, which is really good. Remember, anything close to 1 or -1, or when that absolute value of that number is close to 1, that's a really good correlation. Closer it is to 0, the worse that is. But that's going to allow us to create a function that we can then use on a calculator page. So let's go ahead and do that. So we're going to add ourselves another page, Control, Add Page, Calculator Page. And again, go to Menu. This time, we don't analyze because we're just in the middle of a page, but we're going to do some statistics. And you'll notice, given all those options, we're going to Statistical Calculations. Under Statistical Calculations, you'll notice, again, those regression options. A couple other options as well, but notice the third one down, Linear Regression, mx plus b. So we're going to go ahead and pick that. Now we just need to tell it what our x list is again. So we just go down, remember our x list was called year, and our y list was called stations. And notice that it's going to save that as F1. And that's a real key, is that it's making a function, a usable function, out of that data. So go ahead and press OK. And notice we get all that stuff nicely on there. Again, here's your slope. Here's your y-intercept. We've got our correlation. And now the really nice part is, instead of having to retype all those numbers, we can actually just type in, since we saved our function as F1, I can type F1, and notice how it went bold. It recognized my function. And then I can type in for the year that I want. And remember, we're saying year 50. The year 2020 is 50 years after 1970. So we're just going to find the value at 50 for the function F1. And if we hit enter, 17,196.714. 17,196.714. 17,196.7. Sorry, my memory's not so great. 14 stations. And does that fit with our data? Well, hey, 25, 30, another 20 years down the road, notice we're gaining definitely about 4,000 more stations. Well, hey, in the last 20 years, that's about what we gained as well. So it seems to make sense according to the list and spreadsheet. Hope that helps you find a linear regression line and also how to use it on a calculator page to take advantage of the functions available on your TI Inspire calculator. Good luck finding your linear regressions and have a great day.